Hello students. So in this lecture we are going to discuss about superposition principle of charges, right? In the previous lecture we had discussed about Coulomb's law in vector form, how the force can be calculated between two charges along with the direction, right? See, already you must have learned this principle superposition in your 11th standard waves, right? That according to principle of superposition, the net displacement of the wave will be equals to the individual displacement, vector sum of individual displacement, right? The same thing we will apply here, but we will apply this on the charges. See, one thing is to be known that Coulomb's law is between 2 point charges. It is not between 3 or more than 2 charges, right? If there are 3 charges, Q1, Q2, Q3, then we cannot apply Coulomb's law directly. I cannot write the formula K, Q1, Q2, Q3 upon R square, no, because Coulomb's law is for 2 stationary point charges. So if there are more number of charges, then if we are being said to calculate force on a given charge, we will use this principle, right? You can also say this as the extension version of Coulomb's law. Just extend your Coulomb's law, right? The formula of Coulomb's law, and you will get the superposition principle. See, let us take 4 charges, or you can take 3 charges, no problem. Let us take 3 charges, Q1, R1, Q. Let the position vector be R, Q2, R2. You can take any number of charges. I can take here Q3, Q4, Q5. That will be okay. Let us consider 3 charges. You are being said to calculate force on this third charge. Let this charge be known as third charge. This will be your first charge. This will be your second charge. Let this be third charge. Clear? So according to principle of superposition, we will calculate the force on third charge by using Coulomb's law, but force on this third charge because of this first charge, it will be in this direction, right? So this will give me the force on third charge because of first charge, right? And this charge will exert a force in this direction, this way. This is how. Clear? So this will be the force on third charge because of second charge, right? So this is Q1 charge, this Q2. Q1 exerts a force on Q in this direction. Q2 exerts a force on Q in this direction. So according to principle of superposition, the net force on charge 3 will be equals to F31 plus F32. This is a vector addition, right? See, one of the forces in this direction, other is in this direction, right? So let first vector be this, second vector, this can be drawn here, equal vector. So this is your F31, this is F32, right? This will be your resultant vector. So this completes the parallelogram. Clear? So this will be the resultant force acting on the charge Q because of both these charges. This is what is superposition principle, right? You just have to add the forces in the form of vectors, right? Okay, so F31 will be K, here the charge is Q1, here the charge is Q upon this distance, let it be X. So this already I had explained you in the previous video, right? Coulomb's law in vector form, that don't directly write X equals to R minus R1 or R1 minus R. You just have to go for vector addition. This is R1, this is X, so this will be the resultant. So we can write it as R1 plus X equals to R. So X can be written as R minus R1. Already I have explained this thing in your previous video. So instead of X, I will write it as R minus R1 the whole cube into R minus R1 plus force on 3 because of 2. This will be K, Q, Q3 upon R minus R2 the whole cube into R minus R2. Clear? Right? If suppose one more charge is being kept here, let us say it as q4 and let the position vector be r3, or you can say r4, whatever. We have taken q1, q2. Okay, then let us take q3, r3. So then this will be plus, we have already given the number 3, so take this as 4, plus force on third because of 4, force on third because of fifth, force on third because of sixth, and so on. This is how your superposition principle is being applied. You just have to add the total force acting on a particular charge, but add them in the form of vector. You cannot add the forces directly, because force is not a scalar quantity, it's a vector quantity. If one force is acting in this direction, other is acting in this direction, you cannot add directly. So this is how the superposition principle works. When more than two charges are there, we'll always go for superposition principle, right? You will get a clear picture after solving few questions based on this concept, right? So now in the next video, we'll discuss the questions which are actually very important from the board point of view also. We'll solve few questions based on superposition principle and how to apply Coulomb's law in those questions. Clear?